What's up, party people? Okay, let's look at some two-way tables. You might notice this is graded for the second time, this time through. I like that I had to think about that. That makes things fun. So we're starting with the two-way table, and we've got to figure out some missing pieces here. I'm going to begin adding some of these things in. So we've got the first column with people with purple hair and green hair. And then we've got always wears glasses as our first column of information. I know that to get the total, I've got to add those together. That gets me 76. The other one that I can do right now is going across the green hair row. I know 36 and 44 get me to 80. So we're talking about 180. Plus another 50 gets me to 230, and we've got 235 in total. Okay, looking for other things that we can fill out at this point. Well, we're given 484 total students. And if we know that 44 is the total, we've got 235 students with green hair. That tells us we've got 249 students with purple hair. That seems realistic to me. Let's look at the sometimes wears glasses column for that. Starting with 249, and we're going to minus some stuff like 161 and 40. And we've got 48 there. Finishing this off, let's add down. So we've got 95 plus 8 is 103. And then we've got 160 plus 140 is 300 plus 5 more. Just making sure that my bottom row adds up. So we got 76 plus 103 plus 305, and we got 484. Okay, part one, complete the table. Checkity, check, check, check. How many students wear glasses some of the time? So that's looking at the some of the time column, and this is just how many. So we're looking for a total number, not some kind of a probability. That's just 103. Okay, what is the probability that a student has green hair? If we're talking about green hair, I'm going to switch to a green marker. We're looking at 235 total students that have green hair, and that's out of a total population of 484. What is the probability that a student always wears glasses? Same idea. We're looking for a total population, so that's 76 out of 484. What is the probability that a student always wears glasses given the student has green hair? So let's take a look at this. So given the student has green hair, so I'm living in my green hair row. The probability that they always have glasses on, that's going to be 36. And then out of the total green hairs, which is 235. 36 out of 235. And just to kind of get the notation down, so this would be probability of, I'm going to say always, given green. Cool. The last part of this is question 6, which is about this independent thing. And here we got to really think about, does the probability of a student having green hair change if they wear glasses or not? And that's something that we always have to be a little bit careful of. This is also different than the probabilities that we calculated before, because here we care about never wears glasses, and before we were talking about always wears glasses. So the person who created this question wants you to do a little bit of extra work because they are a jerk. But just kind of looking at this, we know that we have probability of green, and that's going to be equal to 235 over 484. May be useful to convert this to a decimal just for the sake of an easier comparison. So when I do that with my handy-dandy calculator, we get a really long repeating decimal. So I'm just going to call this point 4855. All right, so based on this, we need to figure out the probability of being green which I hear is not easy, given that they never wear glasses. So we're looking at the never wears glasses category. And we've got green hair is 144 out of a total of 305. Let's divide that and see what we get. So 144 divided by 305. And when I do that, I get 0.4721. So these are within 1%-ish of each other. I think that this is a really nice example of one where you could argue either way that yes, they are independent because those are similar enough that within a real population that's understandable, or no, they are not independent because these numbers are not exactly the same as far as these percentages. The big understanding here is that the probability of having green hair is or is not unchanged when you know that someone never wears glasses. Next up, we got a standard deviation section. This will be the first time that this section is graded. And one of the things that might be nice for us to have is one of those templates that has the normal curve for us to work with, or just the idea that we have this normal curve where we have a mean, and then going up one standard deviation, down one standard deviation, gives us 68% of the total data, or 34 on either side. Going up a second standard deviation and down a second standard deviation gives us 95% in accumulated fashion. And then going up a third and down a third standard deviation is going to be 99.7% of that data. This is the empirical rule. These are the things we're going to use to get at the ones that are not technology-based. So listing out these things. So the mean here is going to be 8,500. Going up one and down one with a standard deviation of 450 is going to be 8950 and 8050. Going up one and down one more is going to be 9400. And down one more is going to be 7600. And then going down a third gets us to 7150. And up a third time is going to get us to 9950. Looking at the values that we're searching for, between 76 and 85, that is 2 standard deviations below, up to, just that first, the mean there, which is nice. So we know that if we had both sides, we'd be looking at 95%. If we only have one side, we're looking at half of 95, which is going to be 47.5%. Approximately what percent of Martians live in Salem, Massachusetts earned more than $10,000? I'm going to use Desmos for this, and in doing so, I end up getting 0.000429. So that would be 0.000429. In terms of a percent, 0.0429%. And that's using that probability function that we've used before. While visiting Salem in October, John Jones earns more than most of these people. So more than 84%. I'm going to look at my diagram here. So we know that more than 50% will take me to the mean. A 34% will take me to 1 standard deviation. So we're looking at a value of exactly that first standard deviation. So he made 8950 because that's at 1 standard deviation above the mean. The bottom 12% of green Martians in Salem, okay, this is another technology okay one, because that's not one of the numbers we can figure out. So I'm just going to start with like 8,000, and I got 13%, so that's pretty good. So maybe I'm going to jump to 7,800. That gets me 5%. So cut the difference, 7,900, 9%, 7,950, 11%, 7,958, nope, too small, 7,966, we're at 11.7%, 7,970, 11.9%, so close. And we get to 7,972 at 12%. So we're talking about anyone who makes less than 79.72 is in that bottom 12% of this. Okay, for number 11, we're looking at what's going to happen in 2019. And here we have the mean remaining the same, but the standard deviation is going to be increasing. We know that standard deviation is all about the spread of the data. So this would mean that the data is going from something that's kind of like this, something that's more spread out. What that could mean is that we have more people at the outer edges, or more Martians at the outer edges, that if the standard deviation is increasing to 600, that means the average distance from the mean is now 600. It used to be 450. So there are some things that can cause things like this, and that's just the middle kind of evaporating and the higher and lower ends having more people involved in that. And in society, there are a lot of different things that could cause this, one of which is people moving out of an area, new people moving in, being paid less, while some people are staying and getting paid more. Other things that could cause this are change in employment structures in terms of fewer employees that are being paid regularly and some that are being paid as contractors. Those tend to be paid lower. So there are lots of reasons that can cause the variation to kind of spread while the mean stays the same. Okay, continuing with our studies of the green Martians in Salem, Massachusetts, and now we're looking at a study about shape-shifting abilities. We have some information from the past. The mean age was 81 years that they developed these abilities. So that's that known fact. I would say that this 81 years is the population parameter. And that's the known value within this thing, okay? The sample statistics, those are the results that we get from each of these surveys. So we have 73.2 years from the first one and 62.7 from the second one. So we got 73.2 and 62.7. I'll put years for both of those. These are the same thing. We're looking for the number of years that the average green Martian has before they develop shape-shifting abilities. And in the case of the population parameter, we're talking about the whole population and the true value, which in this case is 81 years. For the sample statistic, these are things that we're measuring. We have to kind of come to terms with whether or not they match these or don't match these. For number 13, we got to talk about this types of surveys that we did. So for the first one, green Martians are coming up to this table and getting a coupon and then are asked about this. This is a voluntary survey. And it's voluntary because they're opting in to get the coupon in order to take the survey. There's some problems with this in terms of the target demographic is green Martians who are interested in pizza, which may be different than green Martians who are not. We don't know anything about that. So this is a little bit problematic as far as trying to get a good sample for the true average here. The second one, where the human resources manager is just asking people on her staff, that's a sample of convenience. And all that this does is give us an idea for the average age of her staff in terms of shape-shifting abilities, which is 62.7 years. For number 14, the third survey being conducted found the average age of 700 randomly selected. By the way, this is a simple random survey, or simple random sample rather, was 78.5 with a margin of error of 2 years. What is the 95% confidence interval? Well, we know that for the margin of error, we said that that was 2 SDs, 2 standard deviations, so we're looking at 78.5 is the middle. And going 2 standard deviations up, we're going to get 80.5. And 2 standard deviations down, we're going to get 76.5. This would be my 95% confidence interval. So what you could say from this, so interpreting the meaning of this, would be we are 95% certain that the true value for the average age of green Martians having their shape-changing ability show up, that average age is on the interval from 76.5 to 80.5. That means that we're pretty certain that on this interval from 76.5 to 80.5, we should have the average age, and considering that what we accepted as a population parameter was 81 years, that seems to be like something is a little bit out of whack there. Not a lot out of whack, but perhaps a little bit, and that could be due to a number of things. Maybe it's time to take a look at the way that we're surveying or asking questions, or maybe it's time to have a new population parameter. Maybe the 81 years is no longer accurate.